Okay, here is your polar question here. So they give you two curves. This is the equation of the line that they're given, and then the other one is a curve, which is given by x equals square root of 1 plus y squared. So first question is find the coordinates of point P. Well, point P is where the line and the curve intersect, so here's the line, here's the curve. I'm going to just set them equal to each other, so 5/3 y equals square root of 1 plus y squared. You have a calculator, so I'm going to just use my calculator to solve. You get y equals 3/4. Here's your y. You can plug it back into here to find, or the other one, to find the corresponding x equation, and x ends up being 5/4. So the point P is 5/4, comma 3/4. It is 1 point for both points correctly. There's another question. It also asks you to find dx dy. So they're not asking for dy dx, but they're asking for dx dy. So you can start with one of the equations. So I'm going to take the derivative with respect to y, 1 plus y squared. Don't forget chain rule. And then use the 3/4 that you know. So dx dy is 3/5. That's 1 point for the answer. Probably would have been easier actually if I just use x equals 5/3 y. You can do the same thing. Or you can find dy dx and then flip it. Okay. Part B. Set up and evaluate an integral with respect to y. So I need to be using dy in this problem that gives the area of S. So if I draw this at rectangle, notice it's always the curve minus the line. So the area of S is going to be 0 to, you must use the y value, so it's 0 to 3/4. The area of that rectangle is right minus the left, so it's the square root minus the equation of the line. So this is my area, and punch this out in your calculator. 0.34657 is my value. It is 1 point for the correct bounds, 1 point for the integrand, 1 point for the value. So 3 points part B. Okay, part C, they're telling you that the equation of the curve in function form is x squared minus y squared equals 1. They want you to show that you can get to this answer. So what you need to show them is that x equals r cosine theta, y equals r sine theta. So you need to show that you understand that relationship. So I want to know what is x squared minus y squared equals 1. If I do the substitution, this becomes r squared cosine squared theta minus r squared sine squared theta equals 1. I want to solve for r squared because they want you to show that r squared equals equal to that function. You can factor out the r squared and you're left with this. Okay, really it's a point for this relationship in the substitution and then a point for getting to the correct equation that they want you to show. 2 points for part C. Lastly, part D. Okay, so they're asking for an integral that represents the area of S using polar. So remember, in polar form, these are our angles that we have here. We have to figure out what this angle is, but notice it's just going to be bounded by this curve. And in part C, we just found the equation of that polar curve. R squared is that. So I know that the formula for an area of a polar curve is 1/2 r squared d theta. So the 1/2 will be there. I just figured out in part C what r squared is, so all I need to do is substitute that in. Okay. The only thing I'm missing is I don't know what the bounds are. So if I look at this graph, this is theta equals 0. This value right here, they don't give us that angle, but I do know that this, if I look at this, let's call this angle beta here. Whatever that angle is, you see this right triangle here, if I drop it down, I know that this y value is 3/4 because I just figured it out from part A, and I also know that the x coordinate is 5/4. So I can use a trig function, a tangent function, to actually come up with that angle. So I know that the tangent of that angle beta is 3/4 divided by 5/4, right? Opposite over adjacent. You can use the invert trig function and you're going to figure out what beta is. So it's whatever the inverse tangent of 3/5 is. It ends up being 0.5404 something. So this is 0.5404. So it is 1 point for the angle, and then it is a point for everything else on the integrand for part D.